Hey y'all, in this video, we're going to learn how to convert powers of 2 bases to other powers of 2 bases. Here's the key takeaway. When all else fails, just convert to binary. Okay, let's give it a try. So, utilize the property of powers of 2, use binary. For example, how many numbers can you represent with 1 bit, 2 bits, 3 bits, and 4 bits? So with 1 bit, I can represent 2 things. 2 bits, I can represent 4 things. 3 bits, 8 things, and 4 bits, 16 things. So we're going to use this special feature of powers of 2 to convert to other powers of 2. Let's look at an example. 789A in hexadecimal to base 2. Now, let's go ahead and write that out. 789A. Okay? And this is in base 16. How many bits do I need to represent 16 different things? So how many bits needed to represent 16 options, 16 different things? You need 4 bits. So what we can do is we can break down each of those places, the 7, the 8, the 9, the A, into 4 bits. So how do I represent 7 with 4 bits? How do I represent 7 with 4 bits? Well, that is 0, 1, 1, 1. 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. And A is 1, 0, 1, 0. So this right here is whatever 789A in hexadecimal was in binary. Let's do another example. EE27. It's going from hexadecimal to binary. And I know in binary, I need 4 bits to represent 16 different things. So let's go ahead and use that capability. E is equivalent to 14. So that's 8 plus 4 plus 2. This 2 is equivalent to 2. So that's right here. And 7 is 0, 1, 1, 1. Okay. Now let's go ahead and go from binary to hexadecimal. We don't need to go to decimal, okay? Because it's the power of 2, how many bits do I need to represent 16 different things? 4. So I'm going to do it in groups of 4. So right here, what value is that? That is 15. What's equivalent in hexadecimal? That is F. That is a 5. That is 8 plus 2, that's 10, that's an A. That's a 5. That's 10, that's an A. So here's my answer in base 16. Think about how much longer it would take you to convert all the way to, what was I going to say? Decimal. And then having to divide that decimal number by 16 to get your base 16. Right? So we definitely want to take advantage of this capability. When you have 2 powers of 2, base 2 and base 16, or other bases that are base powers of 2, take advantage of this property. So we're now trying to convert to base 8. How many bits do I need to represent 8 different options? Well, I need 3 bits. So I'm going to do groups of 3 for this one. So here we go. What is that? That is 5. And that is 1. So here it is in base 18. So here it is in base 8. 1, 5. And if you want, you can do the math to convert base 8 to base 10 and convert base 2 to base 10 and see that they're equivalent. All right, now there are other ways to go from powers of 2 to powers of 2. But But again, that's a lot of rules for you to remember. If you want, there's a great stack exchange, math stack exchange online that you can Google. Basically how to convert a base 4 number to base 16. It's very interesting if you want to memorize more rules for even faster converting. But I think what you can do is just convert to base 2. Okay, so right here we have 1321, 3221. And this is base 4. Okay, so base 4, how many bits do I need? Needed. How many bits are needed to represent 4 options? Right, that's our question. Well, I need 2 bits. So let's go ahead and represent each thing with 2. So 1 is a 0, 1. 2 is a 1, 0. 2 is 1, 0. 3 is 1, 1. 1 is 0, 1. 2 is 1, 0. 3 is 1, 1. 1 is 0, 1. So there's my number in binary. Let's go ahead and convert that to base 16. I need 4 bits to represent a base 16 number. So here we go. So that is 8 plus 1, that is 9. This is 8 plus 4 plus 2, that's 14. That's going to be an E. This is 9. And this is 7. So here we go in base 16. Okay? When in doubt, convert to binary. When you have 2 different powers of 2, both base 4 and base 16, those are powers of 2. All right, we are done with base conversions. Wow, there are quite a lot of videos for that one. In the next video, we'll talk about base arithmetic. See you then.